The latest batch of boards have arrived and are performing well. However, manual production has proven challenging, prompting a need for increased efficiency. While progress is being made on the RGB version library, its completion is pending. I'm exploring the possibility of Raspberry Pi Pico integration because it is much faster and cheaper. I have incorporated additional pre-programmed symbols, accompanied by an image converter for faster animation creation. This feature will soon be part of the current bundle only, with an upcoming PDF guide for usage. I crafted a new orange body, awaiting the RGB enhancement. That concludes this update. Now let's delve into the final assembly tutorial. For the start, make sure the motor turns from left to right. Test the DC motor rotation before you solder any wires onto it. After the test, solder the red and the black wires that correspond to the right rotation. Prepare the main body and 4 M2 6mm screws. Now before we wire everything, I recommend you use connectors to make this device more upgradable. It is just a suggestion. Next, screw all the screws in place. Before installing the DC buck converter, apply 5 volts to the input and set the output voltage to around 2 volts. It takes a few turns. Now prepare these parts for the next step. I must warn you, I have made a mistake here. I placed the buck converter mount over the main body mounting hole. So be careful before you place everything onto the black petals. You will soon find out. Solder the input wires to the buck converter. Take the main body and find the wires from the DC motor. I soldered thicker wires onto the DC motor so I could separate the wires more easily. Solder the red wire to the positive pole and the black wire to the negative pole. Now run the rest of the wires through the main hole. Tuck the wires in and use the 6mm M2 screws and screw them in place. Next, find a place to mount the switch case. Watch this hole in particular, I'll leave it be for later. Here I have mounted everything again. This was that hole I covered, and the mount is no longer over the mounting hole for the main body. Do not forget, you can rearrange every module as you wish. Next, prepare the DC barrel jack connector. Solder a red wire on the back pin. Take all the black wires and solder them together onto the front pin. Mount the power jack like so, and place the cap after it fits. Next, take the switch you choose from the boom list. Take all the long red wires and run them through the switch housing. Run additional red wire too, you will need it for the end. It is a good practice to leave the wires longer than you need them to be. It makes the installation way easier. Cut a small pin from a resistor and solder it like so. With this DPD switch, you can separate the DC motor and the microcontroller when uploading the program. When the switch is off, and when you plug in the USB, the motor will not turn. as it should be. Next, solder the red wires. Rotate the switch so that the soldered pin is oriented to the on side. Use the 6mm M2 screws to mount the switch in place. For the end, solder that short wire and that extra wire from the switch together. Use the shrinking tube to isolate the wires. I'm using zip ties to secure the wires onto the black petal. Ensure that the zip tie's head is oriented on the top of the petal, not from the bottom. I will make some 3D printed mounts in the future instead. Fiddle with the wires around and take your time to make the final mount flat. On the end, cut the excess tails of the zip ties. Now we need to connect the black petals to the main body. Each petal goes over and under with each of its neighbors. Prepare M3 10mm long screws and nuts. Align 2 of them onto the main body mounting hole. Take the M3 screw and screw it halfway without the nut. Before installing the third petal, push all the wires inside the main body. Screw the rest of the screws and prepare the nuts. While holding the inserted nut, screw the screw all the way. Please do the same for the rest of them. Now prepare the vacuum cups and install them onto the same hole on each petal. For the default setup, this mounting spot is a resonance spot. It means that it damps the vibrations of the upper part of the device while the device is spinning. I have made this cut to the blue octa mounts so that vacuum cups can sit perfectly. When mounting, I recommend you leave that one hole free so you can install the vacuum cups. And here it is, all done. For the end, just plug in the hologram and make the first test. I hope you uploaded the example before you mounted the Arduino board like I recommended in the instructions, so you can see if there is any error with the wiring. If the device works, all there is left is calibration and you can start making your own animations, write text, install sensors and more. And yeah, do not forget to lube the commutator every now and then with the gear grease.